Welcome back. We have already seen how a tangent is perpendicular to the radius. Today we prove the reverse. Welcome to Math Simplified HM. It's great to have you here. Before we begin, please like, share this video with your friends and subscribe with the bell icon for more updates. Grab your notebook, use the pause button as needed, and let us get to work. The converse of the tangent theorem, a step-by-step geometric proof. We read the theorem: a line perpendicular to a radius at its point on the circle is a tangent to the circle. Now we will see the setup for this proof. Given circle with center M and line L perpendicular to seg Mn at a point N on circle. What we have to prove? Line L is tangent to the circle. Construction: take any point P other than N on line L and draw segment MP. Logical deduction: 1. In triangle MNP, angle N is 90 degree. Therefore, MNP is a right angled triangle. This makes seg MP the hypotenuse. Logical deduction 2. The hypotenuse is always the longest side of a right angled triangle. Therefore, MP is greater than MN. Logical deduction 3. Since MN is the radius of the circle and MP is greater than MN, point P must lie outside the circle. Now the proof: since P is any point on a line L, no other point except N lies on the circle. Thus, the line L intersects the circle in exactly one point N. Therefore, line L is tangent to the circle. That concludes our proof. Thanks all. The shortest distance to success is a straight line perpendicular to your foundation, like our theorem today. Staying perpendicular to your core values is your shortest path to your goals. Thank you for watching. Please like, share this with your friends and colleagues and subscribe for more updates. Click the bell icon so you never miss a session. Enjoy the great time and stay curious.